Today we're going to be learning about quadratics, so I'll be going over the definitions, a few examples, and then lastly I'll have some practice problems for you to work on. When working with the quadratic function, there are three different forms that you will be working with. The first one is standard form, or general form, and that is y equals ax squared plus bx plus c. The second form is vertex form, and that is y equals ax minus h squared plus k, and h and k are your values of your vertex. So h comma k is the same as x comma y for your vertex. And the last one is factored form, and that is the function of f of x equals ax minus p x minus q, and p and q are your roots of your parabola. So wherever the parabola intersects the x-axis. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. One important part about the quadratic formula is that a cannot equal 0. So the discriminant in the quadratic formula is this portion of the formula right here. So the equation of the discriminant is delta change equals b squared minus 4ac. When working with the discriminant, there are three possible situations that might arise. The first one is that the discriminant is greater than 0, and this means that it is positive, and that there are two real solutions. The next one is when the discriminant is equal to 0. This means that it is a real solution, and also that it has a double root. So in other words, both of the roots are in the same spot, which for a parabola, it would be the vertex. So the vertex is a double root when the discriminant equals 0. And the last one is when the discriminant is less than 0. And this means that there is no real solution. When graphing a quadratic function, you will get a parabola. So a parabola is the graph of a quadratic function. So if we look at this coordinate plane below, I have a parabola pictured, and I'm going to go over some important points on it. So the first point is right here, which is the vertex. So the vertex is the central and most important point on the parabola. The vertex will be the lowest point if the parabola is facing upwards, and it'll also be the highest point if the graph is facing downwards. So this vertex goes very well in hand with the next important point called the axis of symmetry. So parabolas are symmetrical, meaning this side of the vertex is the same as this side of the vertex. Same as well the axis of symmetry. The axis of symmetry takes the x-coordinate of the vertex, and that's the line of axis of symmetry. The next important point is right here. This is the y-intercept, and this is when the parabola intercepts the y-axis. And the next important point is right here and right here. These are called the x-intercepts, otherwise known as the roots. So in this parabola there are two roots, and if the parabola had one root, it'd be called a double root. So both of the points would be at one point on the x-axis, so the vertex would be the double root and the point on the x-axis. So for this first example problem that we're going to be working through today, we have a graph of a quadratic function pictured right here. And so the information it tells us is that the x-intercepts are -4, 0, 6, 0, and 0, 240, and the y-intercept is 0, 240. And so this problem is asking us to write down using the information that we're given with the graph and the description. We're supposed to write down the information in factored form, which is the first problem, vertex form, which is the second problem, and then finally standard or general form in the final portion of the problem. So the information that we were given in our problem was that the x-intercepts are -4, 0, and 6, 0. And also that our y-intercept is 0, 240. So the first part of our problem, if you remember, is asking us to put it in factored form. So factored form of f of x is equal to a x minus p x minus q. And so p and q in our factored form of the quadratic formula are actually our roots, which are also known as the x-intercepts. And in our problem, it tells us that f of x equals -10 x minus p x minus q. So we are told to put in the roots for x minus p and x minus q. So this and this are our two roots. So you have f of x equals -10 x plus 4, because since it's x minus p and this is a negative 4 up here, you do x plus 4. And then also x minus 6, because it's a positive 6 up here, x minus 6, positive 6. So this is the answer to the first portion of our example problem. So the next portion of our first example problem, part B, is asking us to put our quadratic formula in vertex form, which is y equals a x minus h squared plus k. And in the problem, it tells us that f of x equals -10 x minus h squared plus k. So we're already given the a value, we just need to find the vertex, which is h and k. And if you remember earlier, our two x-intercepts are -4, 0, and 6, 0. And so the vertex, if you remember, is the central point of our parabola. So any 2 points that are on the same y, that the same y value can map to it. So if you do 6 plus a -4 divided by 2, you can get the midpoint of these 2 points, which is the x portion of our vertex. So you have 2 divided by 2 equals 1. So h equals 1. And next, you can plug h in to our formula and solve for k. So you have f of x equals -10 x. So now that we know that h equals 1, and we have multiple points that we can use, I'm going to use 6, 0. We can plug these two things into our vertex equation. And we already know that a is 10, so -10, I mean. So we can plug in this for x and y and this for h to solve for k. So we have 0 equals -10 times 6 minus 1 squared plus k. So we have 0 equals negative 10 over 5 squared plus k. We have 10 times 25 plus k. And so we're going to multiply these two. So 0 equals negative 250 plus k. And we want to get k by itself, so we're going to add 250 to both sides to get k by itself. So 250 equals k. So our final answer for B is f of x equals negative 10 x minus 1 squared plus 250. So this means our vertex is at 1, 250. So the last part of our example problem, part C, is telling us to show that our graph can be written in the form of f of x equals negative 10x squared plus 20x plus 240. So if we already know our equation in vertex form, which we did earlier, is y equals negative 10 x minus 1 squared plus 250. So if we have vertex form, then we are able to get it into standard or general form. So the first thing we're going to do is x minus 1 times x minus 1 plus 250. So y equals negative 10 x squared minus 2x plus 1. So how we did that was we did x times x is x squared, negative 1 times x is 1x, negative 1 times x again is negative 1x, so negative 1x plus negative 1x is negative 2x, negative 1 times 1 is positive 1. So now we're going to distribute the negative 10 all the way through. So y equals negative 10x squared minus 20x minus 10 plus 250. So now we're just going to add like terms. Y equals negative 10x plus, there's a plus 20x plus 240. Okay, so example 2 is a discriminant problem. So we're given the equation kx squared plus k minus 3x plus 1 equals 0. And it's telling us that we have two equal roots. And so we're supposed to find the possible values of k, and then we're supposed to write down the values for k, which is x squared plus k minus 3x plus k equals 0 has two equal roots. Okay, so for part A of our problem, we're supposed to find the possible values of k, which kx squared plus k minus 3x plus 1 equals 0. So we're supposed to find the possible values of k in which this equation has two equal roots. And so when there are two equal roots, it's called a double root, which we talked about earlier. And if you remember, the discriminant when it's a double root is b squared minus 4ac equals 0. So this is the discriminant when there's a double root. And so now, using our equation, we have to substitute values in for b, a, and c. So if this is based off our standard form, ax squared plus bx plus c equals 0. So a is k, b is k minus 3, and c equals 1. So now we're going to plug that into our discriminant. k minus 3 squared minus 4 k 1. So now we have to solve for k. So you have k minus 3 times k minus 3 minus 4k, because negative 4 times k times 1 is just 4k. So now you're going to do k times k, which is k squared, k times negative 3, which is negative 3k, another negative 3k, because negative 3 times k, and then negative 3 times 3 is 9. And then you add the 4k at the end. So we have k squared, negative 3 plus negative 3 is negative 6, negative 4, negative 10k plus 9. So now that we have this, we're going to use the quadratic formula to solve for k. Okay, so since we know that k squared minus 10x plus 9 equals 0, we can use the quadratic formula and substitute in a, b, and c into the quadratic formula to solve for k. So I'm going to say k equals negative b plus or minus square root of b squared minus 4ac over 2a. And so for this, a equals 1, b equals negative 10, and c equals 9. So if I plug those into my equation, I have negative 10 plus or minus square root of negative 10 squared minus 4, 1, 9, all over 2. Okay. So if I simplify that, I get k equals 10 plus or minus the square root 100 minus 36 over 2. So that can break down to k equals 10 plus or minus the square root of 64 divided by 2. Now that we have k equals 10 plus or minus the square root of 64 over 2, we can solve for k. So the square root of 64, if we rewrite this, is just 8. So we have 10 plus 8 over 2. We also have 10 minus 8 over 2. And k equals. So that means k equals 9, k equals 1. So this is the answer to A. And in part B, it's just asking us to write down which values for k satisfy x squared plus k minus 3x plus k equals 0, which satisfies that to have 2 equal roots. And that would just be simply k equals 9 and k equals 1, like we got in here. Now I have 2 practice problems for you to do. So I have them both here, and you can work through them at your own pace, pause the video, and after you're done working through them, I'm going to display the answers a little bit after this. So here's practice problem 1. And then here's practice problem 2. So work them at your own pace, and when you're done, you can go to the next part of this video for the answer. Okay, so here are the answers for 1A. And then this is the answers for 1B. And this is the work for practice problem 2A and B. Now this concludes our lesson on quadratics. Thank you for watching.